Okay, so the first thing that we need to do is we need to look at the details. It's a 500-metre running race. And we've got 3 people, same as always. We've got student, Mr. Chandakay, and a graph for Mrs. Albertson. Now, the student has a speed of 1.6 metres per second. So that 1.6 goes down here in our equation. And don't forget to put in your t, 1.6 metres per second, and starts 100 metres ahead of the starting line, and that's where that plus 100 goes. Then Mr. Chandakay, he runs at 2.3 metres per second. So our 2.3 goes down here, and our t goes in, and starts 50 metres behind the start line, and that's why we've got a minus 50 in here. And then for Mrs. Albertson, we get a graph. Well, she has gone from, we're first of all going to work out her speed, her gradient. She's gone from 150 down up to 500. So her rise equals 150 down all the way up to 500. It's 650. And her run equals, that's how far across she's gone, how much time she's taken to run that far, and that is 200 seconds to run 650 metres. Okay, so what we're going to do now is on calculator, 650 divided by 200 equals 3.25. 3.25. So her equation is D equals 3.25 T. Now, she started at 150 before the start, behind the start line, so she's got a minus 150. And that's her equation. So now we've gone to Desmos, and what we're going to do is we're going to type in each person's graph, but we need to replace our D's with Y's and our T's with X's. So Mrs. Albertson looks like Y equals 3.25x minus 150. And the second one we have is 1.6. Sorry, Y equals 1.6 x plus 100. And then we have y equals 2.3 x minus 50. Now, this race is a 500-metre race, so I'm going to tell people where my finish line is by putting it on the graph, and I'm going to type in y equals 500, and I'm going to make it a line that just starts at 0. And then I'm going to work on making these lines the right length for a race, because I mean, you don't start at negative time and you don't keep running after the race line. So I'm going to type in 2 things, which I'll show you in a minute. So what I've added is that we want our x's to only start from 0, because you can't really have negative time. So that's that bit. And we want our y's to finish at 500, because that's where the race finishes. And once you've got this once, you can actually just copy and paste it to the other 2 places where you need it. Okay, so here's our graph set up for us, ready to use. And you know, we can see a lot of things in that. We can see that the person who was red, who was Mrs. Albertson, she actually got first. And we can click and see her time. And if we click and hold, we can make it stay. So we're going to get our times to stay. Yep. And we're also going to get our intersection lines, intersection places, because that can be useful later. So we've got a cross over there, a cross over there, and a cross over there. If they won't stick, just write them down, okay? So I'm going to make sure I've got my three crossover places. All right, so yeah, you may have to write them down, but it's a good idea to find out where your intersection places are, and certainly find out what your finishing times were on this graph. Okay, so we're ready now to copy and paste it into our document. So that's what I'm going to do. I actually use a thing called snipping tool, and if you've got it, it should be probably one of the best things that you've got on your computer. So I'm going to copy that, and you're welcome to send it to me, and I will print that as your graph. So here we go. I'm just going to pause for a minute while I paste that in. So we've pasted the graph that we've drawn into this document here, but of course you're just going to send yours to me and I will print it out for you. And then what you need to do too is you need to do lines down from the finishing times, just to show that you can read off the graph the times when the students finished. And you need to do some algebra to prove when they finish. So Mrs. Albertson, her race was 500 metres, everybody's race was 500 metres. Her equation was D equals 3.25t minus 150. So we want to find out the t that she took to do 500. We want to do that using algebra. So here's the equation, and then my minus 150, I took it to the other side of the equals and did the opposite. I added it. When I did that, I got 650. And finally, my t is still not on its own. It's times by 3.25. Undo that by dividing by 3.25. 650 divided by 3.25 gives us 200 on our calculator. So she was first in 200 seconds, and I need that sort of statement. Mr. Chandakay, his equation was D equals 2.3t minus 50. I'm going to undo the minus 50 by taking it over here, and we've added it. And then my t is still multiplied by 2.3. Undo that by dividing by 2.3. On the calculator, we find that 550 divided by 2.3 is 239 seconds. So he's in second place because he took 239 seconds. And finally, the student, well, their equation was D equals 1.6t plus 100. So I took the 100 and I did the opposite with it on the other side, minused it, got 400. Divided by 1.6 to get t, and got an answer of 250. So the student is third in 250 seconds. Now this is all you need to get achieved for your linear algebra assessment.